Hey, it's Karma here again, and I don't love AP calculus. So if it seems like I'm bored to death, that's why. But I'm just trying to get as much done as possible before the 30-minute mark. So hang on tight, guys. So our first unit is related rates, I believe. Some of these notes might be out of order, so don't quote me on that. Because this does not have anywhere on it where it says unit 1 or anything. Nothing does, so I'm just assuming this is unit 1. Draw a figure if necessary and choose variables for all unknowns. Then write what is given and what is found using your variables. Write an equation relating the variables. And if a quantity is changing, it must be represented with a variable letter. If a quantity is constant, it must be represented with a number value. Look for secondary relationships between quantities to reduce the number of variables. Implicitly differentiate both sides with respect to t. Substitute normal number values and solve. So you're going to need your geometry formulas for this, and if you don't know them, I suggest knowing them. I'll go over all of them here, though. Right triangle, you have the Pythagorean theorem, a squared plus b squared equals c squared. Then you have the area, which is half of b times h, or base times height. Circle, your area is pi r squared. Your circumference, or the outside of the circle, is 2 pi r. Sphere, the volume of a sphere is 4/3 times pi r cubed. Your area for a sphere is 4 pi r squared. The cube is e to the third for your volume, and for your area, it's 6e to the 6e squared. The 6 is not squared, it's just the e. I feel like that's kind of confusing just to say, but if you saw it, it's just e that's squared, not the 6. The 6 is multiplied by e squared. Your volume for your cone is 1/3 times pi r squared times height. Your rectangle is obviously your length times width for your area, and for your perimeter, it's 2 times length plus 2 times width. Now for differentiation, might as well go over it right now because I have a paper that has all the rules for differentiation. So if k is a real number, if you differentiate k, it's going to be 0. By the way, differentiation is the slope of an equation. So if you had a graph that had a slope of 1, the entire equation for that graph would be 1, like y equals 1. If x is to the power of n, which n is a real number, just like k, it would be n times x to the power of n minus 1. So, for example, if you had x to the power of 2, x would be multiplied by 2, and then there would not be a power for x because the power would be 1. E to the power of x is still e to the power of x. E does not change. Okay, so if a is greater than 0 and a does not equal 1, a to the power of x equals a to the power of x times ln a. So I never really got that one. I'm going to be completely honest, but if you do, great. Sine differentiated is cosine. Cosine differentiated is negative sine. That's going to, if you're newer to differentiation, that's where you're going to get the most tripped up. But for most of you, this should be review if you have taken AP Calculus. Tangent, if differentiated is negative 1 over sine squared, or negative cosecant squared, times x. No, no. Sorry, I'm like out of it, man. I need to lock in. I'm tired. It's like 9 in the morning. Not 9. Jesus. They're all all numbered. That's where I'm partially getting confused as well. ln x, if differentiated is 1 over x. Logarithm a x, sorry, the a is like the little number underneath the logarithm, is 1 over x ln a. Arc sine, if differentiated, is 1 over the square root of 1 minus x squared. Arc cosine is the same thing but negative. Arc tangent is 1 over x squared plus 1. Arc cotangent is the same but negative. Now the actual rules, so u and v are both numbers that are in these like rules, so just keep that in mind. But the first one is u plus v, but they're both being differentiated, like there's parentheses around them. These are all like plus, minus, multiplied or divided in the differentiation process. Like there's parentheses around them with a little differentiation, like apostrophe. So u plus v differentiated is equal to u, the differentiation of u plus the differentiation of v. So if it's u minus v, the same thing, basically. The differentiation of u minus the differentiation of v. If they are multiplied, it's the differentiation of u times v plus u times the differentiation of v. Now, if it's u divided by v in the differentiation process, the differentiation of u, times v minus u times the differentiation of v over v squared. And the last one we have for a rule is k is a constant, a real number, like the first differentiation I told you about. It's k times u, but then differentiated, it's k times the differentiation of u. So k does not change, but it also does not turn into 0. Okay, that's all you need to know about differentiation for now. I'm trying to get through as much as I can within like 30 minutes, so sit tight. This is an example. I don't know if it's a good example because I don't remember if I took good notes or not. You also will need your unit circle if you still have that. I don't know if other classes also did that. But basically you need to know all your units for pi and shit. I don't know. So basically, all this is essentially for the related rates is just draw a figure, write what's given, write an equation, changing variable, constant number, secondary relationships, implicit differentiation, and then substitute numbers. That's literally all it is. I can't even explain it with the examples, because the examples she gave us were really fucking weird. Sorry, my language, but like, this is just how I talk to my friends about the subject, so this is just how it's coming out. But I really just don't know how to explain that. You get it, or you don't. If you need to look more into it, I suggest that chemistry teacher, I think he's named. I don't know, but he's on YouTube. He does a good job at explaining it, way better than I do. Like I said, this is all for studying purposes, so don't trust me with everything I say. Now we have limits, unit 2. So the limit of x to c of fx is equal to L, uppercase L. That really doesn't mean anything on its own. So, right hand and left hand limits. Basically, your right hand limit is limit of x to c plus, like plus is in the little power spot or whatever, of fx. So like anything, so it's like the line is coming from the right to the left, I believe. Yes, from the right coming to the left, and wherever it comes up at point C is your right hand limit. Now the left hand limit is the limit of x to c with the little minus on the top of it, basically, of fx, and it's coming from the left to the right to the point of C. And wherever it ends up at the point of C is your limit. Now here, fucking gnat, what? I thought the gnats weren't supposed to come back yet. It's still cold. Anyways, theorem. Okay, so limit of x to c of fx equals L if and only if, so it only exists if the right-hand limit is equal to the left-hand limit. Because, as we might probably know now, graphs can be split up with piecewise functions and other things. So if the right-hand limit and the left-hand limit do not match up at point C, it does not exist. Or if it doesn't, I don't know what I said. But if it doesn't match up, it doesn't exist. I think that's all for this. Oh, properties. Properties of limits. I'm not going to say the whole name for these because it's just lengthy. But I'm just going to say limit of fx and limit of gx. Those being your functions. So, limit of fx plus gx equals limit of fx plus limit of gx. It's actually probably all the same, except when you get to 5. But if you're adding, subtracting, multiplying, or dividing, chances are it can be separated into 2 limits with the same sign, same places, things like that. So it's just like how you'd expect it to go. if you need further clarification on that, just comment. Just comment and I'll just explain it in the comments, whatever. Then for 5, if there's a constant like k being multiplied inside of the limit with fx, you can just move that outside of the limit. So like to the beginning of the limit, right before it says limit. If fx is to the power of something, like, let's say half, so like it's a square root, you can bring that square root over the entirety of the limit. And if the limit is x to 0 and sine x is over x, it equals 1. This one we only have examples for, so I don't know how well I can go over it. But if you're doing limits and 0 is if only the top part, oh my gosh, what is the numerator? If only the numerator of the function is 0, it equals 0. If only the denominator is 0, it's infinity. But if it's 0 over 0, it can be practically anything. To figure that out, you have to factor, or trying to think. Excuse me. You have to factor, or you can multiply it by the conjugate, which is really just a fancy way of saying you take, let's say, for example, the square root of t plus 2, and then subtract it by the square root of 2. You just literally multiply the whole problem, like the numerator and the denominator, by the square root of 2, or t plus 2, plus the square root of 2. That, I don't know. I really don't get. This was the hardest part of limits for me, because the rest is actually pretty simple, but whatever. Then you can do trigonometry with like the little sine thing I was talking about and whatnot. That's about it. Now we have the sandwich theorem. If g of x is less than or equal to fx, and that is less than or equal to h of x, for all of x that does not equal to c, so like not a certain point in some interval about c, and limit of gx equals limit of hx equals L, then limit of fx equals L. So it's just saying like that f of x can be in between two intervals, and it kind of just like, or not intervals, sorry, functions, and it just kind of like is in between them, except for one point. That's the best way I can explain it. Then there's horizontal asymptotes. So there can be multiple kinds. The line y equals b is a horizontal asymptote of the graph of a function if of a function y equals fx if either limit of x to infinity fx equals b, or limit of x to negative infinity fx equals b. So you can have it above and below the horizontal asymptote opposite sides of the x-axis. You could have arctangent, the graph of arctangent, where it's in between two horizontal asymptotes. Or you can have it like whatever this function is we drew, where it can like go above and below. It's like sine or cosine. There's a horizontal tangent, or horizontal asymptote, sorry, where it just goes up and down from. Vertical asymptotes. The line x equals a is a vertical asymptote of the graph of a function y equals fx if either limit x to a plus fx equals to positive or negative infinity, or the same thing, but it's a minus. Or negative a, whatever. I don't know. So like the same thing I was talking about with the horizontal asymptotes, where it can go, except it's just it goes, they're both on these two like separate lines are on opposite sides of the vertical asymptote, but just on different x or y axes, just on separate sides of the y axis. Jeez. I think that's it for limit. No, that's not the end of limits. This is really long unit, so whatever I don't get done today. I'm gonna at least try to get through unit 2. This is a really long class. There's 8 units, so just having to yap the whole thing is not the best thing to do, but whatever. A right-hand behavior model for f is if and only if limit of n to infinity is okay. So basically, the limits, or the right-hand behavior and the left-hand behaviors are if fx equals gx. That's about it, I think. Continuity. Function y equals fx is continuous on an interior point of C if its domain if limit x to c of fx equals fc. So there's a bunch of reasons why they can't be continuous. But essentially, if there's a solid point at C, it's continuous. If the line breaks off at C, it's not continuous. Like if there's 2 lines and they both meet up at C, or they don't meet up at C, then that's not continuous. If there's a vertical asymptote at C, it's most likely not continuous. Yeah. Or if there's a jump at all, it's not continuous. I think we're almost done with this packet that I'm looking at. Intermediate value theorem. A function y equals fx is continuous on the closed interval a to b, takes on every value between fa and fb. If y of 0 is between fa and fb, then there is a c in a to b that y0 equals FC. That is it for limits. So we're moving on to the second part of Unit 2, which is rates of change. The average rate of change of a quantity over a period of time is the amount of change divided by the time it takes. So FB minus FA over B minus A. Sorry if it seems like I'm rushing now. I just really want to get this done before 30 minutes because I don't want to make you guys sit through a bunch of yapping that you probably don't care about. I mean, you always have the choice to leave if you want, but like, I'm trying to make this entertaining. I'm sorry. Maybe I am with all my stammering and like, whatever. Anyways, the slope of a curve, y equals fx, at the point P, at the point P, let's just say P, is the number, m equals limit h to 0, f of a plus h minus f of a over h. I don't get that. I'm sorry. But the tangent line, tangent line equation is y minus fa equals m times x minus a. Normal line would be y minus fa equals negative 1 over m times x minus a. Is there anything else I need to go over in here? I will try to do FRQs on here at some point. But yeah, that's about it for Unit 2. We are under the limit, thank God. This part of the series, AP Calculus, is going to take a lot longer because obviously it's going to be spread out because I don't want everything to be in like, at the same time because I feel like that drags on and gets boring, so I'm mixing it up. The next episode I do after this will be AP English Language. So sit tight for that. I don't know how that's going to go. But yeah, I hope you enjoyed this episode. If you didn't, sorry. This is literally my least favorite subject of all time. I don't know why I took this class. It's actually the worst I've ever dealt with an AP class because most of mine are actually kind of easy. So, yeah, I hope y'all enjoyed. If not, I apologize. But I still have to get this done for studying reasons and helping me teach others, or teaching others helps me learn personally. So, yeah, I really do hope that something got through you today. Or if it didn't, I apologize. Whatever. I hope to see y'all soon. Probably Monday. I don't know when I'm recording all these. I know when I'm posting all of these, but recording them is just like out of whack right now because I don't have like a solid schedule for recording. Probably today, because today's Wednesday. So I'm probably going to record most of them on Wednesday or a Thursday. But whatever. I will see you guys at the next recording. Bye.